very good. Okay, so today we are going to talk about 2.8, which is graph, linear.
So we're done with 2.7?
Yeah, I said we were just doing one thing, okay? Inequalities. Okay, graphing linear inequalities. So, look at the title, people. Do you need to be able to graph a line? Yes. Should you be able to graph a line? Okay, so we've already studied it more than once, okay? So, but these are not just lines, they're inequalities. Does anybody know what you do when you graph? What's the difference between graphing a linear equation and graphing a linear inequality?
Sometimes they have
Oh, Lauren. Lauren said there's, you got a shade, graph and shade. And the line, you have to decide, is the line a dotted line or a solid line? Now, word out is that these new fangled calculators you people have, they like dot the line or make a solid line. Is that true? Okay. The old ones don't do that. Okay. So used to, we had to have that knowledge in our heads. Okay. So if you're using my calculators, you'll need to know the difference. All right. So let's do a weirdo problem first, and then we'll go on and do some graphing problems to make sure you know how to graph. All right, so here's the kind of strange problem. It's not very difficult. So which ordered pair is a solution of 2x plus 5y is greater than 9? Okay, and I'm going to give you some choices. Like what? Multiple choice test. -4, -1, or 2, -4, or -2, 3, or 17, -496. If this was a college test, it would say or A and C, or B and D, or all of these, or none of these. Have you ever taken a test like that?
Yeah.
I hate those. But that's what they do sometimes. All right, so tell me this. If it is a solution to this inequality, what kind of statement is it going to make when I plug it in?
I don't know.
Yeah, you do.
I don't know.
If I plug a point in and it's a solution, it makes a true statement. That's exactly right. That was too easy for you, okay? It makes a true statement. So if that's what I'm going to do, guys. I'm going to plug each one of these points in, and I'm going to find the one that makes a true statement, okay? So the first one I'm going to plug in is this guy. So I'm going to go over here and plug him in and work it out. So 2 times -4 is x, plus 5 times -1 is y, is greater than 9. And heavens knows we're taking a test, so we probably left our brain at home. All right, so I'm going to pull out my handy-dandy calculator. Oh, I don't know why I did that. Anyway, and I'm going to go 2 times -4 plus 5 times -1. So -13 is greater than 9. True or false?
True. No, false.
False, okay? False. So, it's not
Yeah,
A.
like you said, with the line.
All right? So now let's look at B. I'm going to plug this guy in. 2 times 2 plus 5 times -4 greater than 9. Well, I can still do it on my calculator. 2 times 2 plus 5 times -4. -16 is greater than 9. True or false?
False.
Alright, so it's not him. So I'll check the next guy. This is C. 2 times -2 plus 5 times 3 greater than 9. I'm going to do this one in my head. -4 plus 15 greater than 9. 11 is greater than 9. True or false?
True.
So that's my solution. It's the easiest way to do it, guys. Okay? Easiest way to do it. Anybody got a question? Okay. So now we're gonna graph some problems and make sure that you know how to not just graph a line. See, this is another opportunity to learn how to graph a line. So I'm gonna graph 2 graphs on every coordinate plane. So I'm gonna make my coordinate plane in the middle. I'm gonna do a problem over here and a problem over here. Okay, just so you know where we're going. Are y'all drawing a coordinate plane? I didn't hear your hammer and chisel.
I don't have it.
Here, go ahead.
What is that
All right,
example what?
example 2A. So, negative 2y minus 5 greater than or equal to 1. All right, so I'm going to graph this thing. Now, when I showed y'all how to graph lines, I said we can solve for y, put it in slope-intercept form, okay? Find the slope and the y-intercept. Or I showed you another way where you could use the x-intercept and the y-intercept. Y'all remember that? That's not the best way to graph these, okay? So I would say solving for y would be the best way to do this. So tell me what to do if I'm going to solve for y.
You add 5.
Add 5 to both sides. So now I get negative 2y is greater than or equal to, what's 1 and 5?
6.
6. Now what do I do?
Divide by negative 2 is flip the
Divide by
sign.
negative 2. Oh, flip the sign. Why? Whenever you multiply or divide by negative, you have to flip the sign. What's 6 divided by negative 2?
Negative 3.
Negative 3. What does this look like when I graph it?
Horizontal.
It's a horizontal line. Y'all, some people still haven't learned that, even though we said it and studied it about 4 times. Okay? I've even showed you a silly way. This Y is an upside down H. He's screaming at you, I'm a horizontal line. So, a horizontal line where Y is negative 3. Okay? So I'm going down here on the Y-axis. Here's negative 3, and I'm going to draw a horizontal line. Before I draw it, I want to ask you, is this a dotted line or a solid line?
Solid.
Very good. What makes it solid?
Or equal to.
Yeah, that or equal to. What that actually means is that my line is included in my solution. Okay? So if a point lies on the line, it will still be part of my solution. Okay? If it's a dotted line, it's up until you get to the line, and the line is not included. So here is my line. Now, I want the y's that are less than negative 3. Would that be above this line or below the line?
Below.
Very good. Ta-da! You okay?
I'm green.
Anybody got a question? Everybody good? I'm going to look at my inequality and ask what kind of y's are they asking for? Okay? I want the y's that are less than negative 3. It's either going to be above or below. So where are the y's that are less than negative 3? Would they be below the line or above the line?
Below.
Right. So that's how I know. And I'm gonna, when it's a slanted line, I'm going to show you a good way to do it. Okay? Show you an easy way to do it. All right. So here's 2b. Are you ready?
Yes.
2b. X is less than 1. Go. You do it all by yourself. I'm graphing it on this same coordinate plane.
X is less than 1. Pretty easy.
Okay, you got it?
Yep.
All right. So, what kind of line is this?
A dotted line.
A vertical line. Guys, do you think I'm going to test you on that on the test?
Yeah.
Yes.
No, I am. Okay? I mean, you can remember it the silly way. This Y is an upside down H. He's a horizontal line. This X is like 4 V's all stuck together, screaming he's a vertical line. What if I don't remember that? Do I just guess?
Yeah.
What can I do?
Look at the.
Hello, people. You've got a dang calculator. Okay? You go to Y equals. Go to Y equals. Okay? And Can I plug this in my calculator?
No.
No, this is not a function, people. Okay, a vertical line does not pass the vertical line test. All right, so my calculator is a function-based utility. That's why he only tells me one answer to a problem when sometimes it has two answers. Okay, because he's a function-based. Every x has only one y, so he won't graph this. But by dog, he'll graph this one right here. -3 graph. Now, if I know if the y makes a horizontal, surely I can figure out that the x makes a vertical. You see what I'm saying? Use your tools, people. All right, so a vertical line at 1, right here. Solid or dotted?
Dotted.
That would cost you a point on every one that you did wrong. Okay? Now, which side of this dotted line do I graph, do I shade? I want the x's that are less than
Yes.
the left. Okay? Anybody got a question?
No.
All right, so here's my next one. I'm gonna do the same thing down here with 2 more graphs. So I'm gonna draw me a little coordinate plane. Okay, so here's my first problem, example 3A. Y is greater than -2x. Okay, so I told you the best thing to do was to always solve for y. Well, guess what, people? What? It's already solved for y. Okay, so that was pretty easy. What's my slope?
It's -2.
Oh, -2. Oh, Miss Davis said that if you have a negative slope, those are probably, you're more likely to miss that one. So right now I need to know, I need to be on point. I need to be paying attention. I need to check and make sure my line's going down. Okay? What's my y-intercept? 0. So I'm gonna go to my y-intercept, 0. I'm gonna use my slope, which goes down 2 and to the right 1. Down 2 and to the right 1. Before I draw my line, what kind is it?
Dotted.
Okay. So I'm gonna draw me a dotted line. Okay? Now, I'm gonna show you how you were taught to do this in Algebra 1. Okay? And then I'm gonna show you a trick. Okay? We don't teach tricks in Algebra 1s, we only teach basic skills, basic algebra skills. Okay? Because that gives you understanding. Tricks are fine, but not if you don't have any understanding. So, here's what you were taught to do. Pick a point. I don't care where it is, as long as it's not on the line. If I could pick 0, 0, I always told my kids to pick 0, 0. All right? I can't pick it here because it's on the line. So, I'm going to pick that point right there. I could pick whatever point that I wanted to, but I'm going to pick 1, 1. Okay, now here's what I'm going to do. I'm going to plug this point back in that inequality. If it makes a true statement, then every point on this side of the line makes a true statement, and that's where I'll shade. Okay? If it makes a false statement, then the true statements must be where? The other side of the line. So then I would shade the other side. Okay? So I'm going to plug it back in. What's y? 1 greater than -2 times x is also 1. So 1 is greater than -2. True or false?
True.
True. So what that tells me is that I should shade this side of the line. Do you agree?
Wait, so the side of the statement that's true is the one that you're gonna.
Okay, so if it makes a true statement, you shade on that side. If it makes a false statement, you shade on the other side. Okay? Because solutions make true statements. So if this one point made a true statement, then any point that I picked over here would make a true statement. If it made a false statement, then the truths must be on the other side. So I would shade the other side. Okay? Now I'm going to tell you this is the way I teach my kids how to do it. Because you should know that. Okay? That's Algebra 1. So here's what I tell my kids. Hey, put your finger on the y-intercept. Okay? Now read what your statement says. We solve for y. All right? In this case, we didn't have to, but if we did, we would have. All right. Now read what you want. I want the y's that are greater than. Would that be above my finger or below my finger?
above.
So that's where you shade.
Cool.
See what I'm saying? Okay, alright, so I'm gonna give you a problem. Man, I'm gonna bust out on this problem, okay? He's gonna have a little bit of everything in there, and I'm gonna give you 2 minutes to do it, okay?
Exactly.
So here you go. 5x minus 2y is less than or equal to -4. Go. 2 minutes. Okay, y'all got it? Yep. Alright, so here's what I'm gonna do, okay? I'm gonna pretend like I'm taking a test, and I'm gonna say out loud what I would normally say out loud in my head, okay? I couldn't say it out loud, because I would get in trouble. But I am gonna tell you, because I want you to know, some kids are like going, how do they do all that stuff? Like, this is how we do it, people, alright? So, I'm looking at this, alright, I gotta solve for y. So, I'm gonna subtract 5x from both sides, or pull the x on the other side and change the sign, whichever way you like to think about it. My x should go first, so -5x, and then my -4. I gotta divide by -2, ding, ding, ding. Oh, remember when you divide by negative, you have to flip the sign. A -5 divided by -2 makes a +5 halves x. A -4 divided by -2 makes a +2. So, my slope is 5 halves, and my y-intercept is 2. So, I'm gonna go over here, I'm gonna graph it in purple, okay, so you can tell the difference. So my y-intercept is 2, so I'm going up to 2. My slope is 5/2, rise over run. So up 5, 1, 2, 3, 4, 5, over 2, and here's my point. Well, I can't do that again, so I'm gonna go backwards, which means I'm gonna go down and to the left. A negative over a negative will make a positive slope. So down 1, 2, 3, 4, 5, and left 2. My line is a solid line. Okay, I'm gonna put my finger on my y-intercept. I'm gonna look back up here and I'm gonna say, I want the y's that are greater than. That would be above my finger, so I'm shading right here. Are you good? Did everybody do okay? Okay. Got a question? All right, so did you know that my calculator will do this? Now here's the deal, okay? You have to solve for y, so do you have to have some skills? Guys, do you think I'm gonna test you on if you know how to flip the sign, or if you know when you're supposed to? You can bet on it, okay? You can bet on it, it's gonna be on there. All right, so I'm gonna go to y equals, I'll clear this out. I'm gonna put my equation in there. You could use the fraction button, I don't usually use it. +2. Okay, so now I'm gonna go all the way back over here to the left. Do you see this little blinking line? Okay, when he's blinking, he's asking me, hey, what you wanna do? Alright, so if I press the enter button one time, I could choose a skinny line or a fat line. Alright, like no, that's not what I'm looking for. So I press enter again. Oh, it shades the upper region. I wonder what that is. Greater than, very good. If I press it again, it shades the lower region. That would be less than, okay? So I'm gonna go back to the greater than. It has other things on here. It has a little tracer ball, just a ball, a dotted line, and then back to this one. So when I graph it, it should look just like my graph right here. Y'all, is there any reason to miss any of these on the test?
No.
Y'all, you ought to have the skills to solve inequalities, okay? So, come on, people. I expect to see some outstanding grades on this test.
How do you get the dots off of it? Yesterday, I think you put dots on the graph.
Oh, I put dots on your graph. Do this. Go second and format, which is above the zoom. And you see where yours says grid dot on? Go back and turn it off. Grid dot off.
Okay, thank you.
Okay?
That's funny.
All right. So, here we go. One more problem. Are you ready? Does anybody have a question? Everybody okay? One more problem. Here it is. My favorite problem. Example 4. Y is greater than. Let's go draw a graph real quick. Like I can do this. I can draw a graph. Okay, you got it? Yeah. All right, here we go. Y is greater than -2 times the absolute value of x minus 3 plus 4. Oh, here we go. You have 1 minute.
To graph it?
Yeah. I mean, yesterday you were graphing them in like 15 seconds, so.
That wasn't you.
Yeah, I don't know who, I think it was you,
It was
Chris.
you.
I don't remember anyone else.
Like she said, what she does is easy, but
That's right. That's the way it's supposed to be, you know, that's what kids always say, so teachers make it true. We do all the easy ones and give you all the hard ones.
I did it. No, I did it. I mean, he did it.
I don't want him to do it, I want you to do it, without a calculator.
Too late.
Oh, my bad.
Is it the other? Okay. No,
What do you not know how to do?
That -2.
Oh, okay, I'll show you. Do you know where the vertex is?
yeah, put your in there.
Okay, make a dot there,
Oh,
and we'll go from there. All right, everybody ready?
no, yes. Whoa.
All right, give you 10, 15 seconds.
Don't do that. Don't do that.
7, 6, 5, 4. This is practicing under pressure, people. That's what y'all need to practice, okay? All right, so here we go. First of all, this is an absolute value equation, all right? So when I graph it, it's just a line, right?
It's a V.
It's a V. Very good. How many times did we say that?
A lot.
A lot. So there's still gonna be 2 to 3 people in here, and they're gonna, on the test Monday, they're gonna graph a line for every absolute value question, and they're gonna miss it. I'm like, I don't know what to do for you, okay? So what does this negative do to the V?
Make it go down.
Yeah. Y'all look, your V is naturally like this, so that negative is gonna make it open down instead of opening up. What is the 2 affecting?
This was.
The slope. So instead of it just being a normal, like a parent function like this, he's gonna be skinnier. It's a vertical stretch, okay? So what does that -3 do to my V?
Moves it.
Where?
Oh, no,
What?
to the left.
Right.
Right 3, okay? He's with an X, so he is an X, he moves left or right, opposite of what you think. So I'm gonna go right 3, 1, 2, 3. So I'm right here, are you with me?
Yeah.
What does the +4 do to my V?
Bring it up.
1, 2, 3, 4. So does everybody agree that that is my vertex? Are you with me? Now I'm gonna use my slope right here, and I'm gonna find the other points. It's going down, so I'm gonna go down 2, and to the right 1, and to the left 1. And there's my V. Is it solid or dotted?
Dotted.
Okay, now here's what I love. When a math person makes a rule up, it's a rule, people. And you can use it all the time. So I'm going to use that same rule that I taught you. All right? I'm going to put my finger where it crosses the y-axis. And then I'm going to look back over here and I'm going to ask, what kind of y's do I want? I want the y's that are greater than. So would that be above my finger or below it? Above. Is that outside the V or inside the V? Because those are the only two places. Okay, so outside. Don't forget to shade both sides of it. All right, so it's everything outside the V is shaded. So any point that you pick in this shaded region will make a true statement in here. Can I pick a point on the line?
No.
Why?
It's not
It's
included.
dotted. It's not included, it's dotted. Okay? So the points on the line will not make true statements, they will make equal statements is what they will make. Okay? And it's not or equal to. All right, anybody got a question? Okay, so listen to me. I'm saying this on the tape. So when someone says, no, Miss Davis, you didn't tell us that. Your worksheet is due Monday. Your test is Monday. You need to make sure you have 2.4 out of your bucket and do not leave your papers strewed all over my cabinet. Okay? And make sure that you know what you did wrong. Some people still think perpendicular slopes are just opposites. They're opposite reciprocals, okay? So take care of that. Michael, we're done. Thank you.
Can you tell us what the whole, like, what part